So in this video, we're going to look at completing the square, and we're going to do that through an investigation question. And I'm going to be toggling back and forth between our presentation and my document camera. If you have algebra tiles at home, it might be beneficial to have those with you. Otherwise, I've provided a link in this lesson that you can use instead. So what we're going to look at is this quilting problem. So Jessica has a quilt shop. She sells many colorful quilt blocks for people who want to make their own quilts. She has quilt designs that are made so they can be fit to any bed. And she's basing her designs on a square. That's our important part. They're built based on a square that can vary in sizes. So she calls the length of the side of the square for a basic square X, and the area for the basic square would then be X squared. That way she can customize the design and make bigger or smaller squares. So the first thing that we're going to look at is she's going to add 3 inches to the side of her square, and our goal is to find the area of the new square. So I'm going to go over to my document camera. This is the link here for the virtual algebra tiles that you're more than welcome to use. You go under this link this tab that says algebra tiles. These would be your X tiles, these would be your X squared tiles, and these would be your 1 unit tile. So why does this matter? Those of you that had me in Math 1 know that I love using the box method or the area method for these types of questions. So this was her original quilt square. So I'm going to actually, on the outside of this square, use my side lengths. So this had a side length of X and X. So inside will be the area. The detached portion is going to be the side lengths. So what she's doing is she's adding 3 to both sides. I'm going to add 3 to that side. I'm going to add 3 to this side. And my goal is to find the new area. So these ones are going to be a length of X and a width of 1. These are also going to be, a length of X and a width of 1. So again, the detached portions are just showing you my side lengths. The inside portion is where we're actually seeing the area. So then this last corner down here, I need to add in a bunch of 1s. And then the inside will show us our new area. All right. So I had a side length of X plus 3 and another side length of X plus 3. And then inside all of this attached portion would be the area of the quilt square. So this was X plus 3. This was X plus 3. And I'm going to take these away now so we can look at just the area itself. So here, it's still a square because both side lengths are exactly the same. So I have the X squared portion. I have 3X, 3X, and 9. So I'm going to go ahead and go back to our presentation. And it says use your diagram and the equations a of x equals x plus 3 squared to explain why the area of your quilt block is also x squared plus 6x plus 9. Well, I'm going to come back to my document camera. So this would be one of the lengths of my square sides. This would be the other length of my square side. So if you think back to Math 1, if I multiply these two pieces together, that would be x plus 3, the quantity squared. That's one way to represent the area inside of this square. The other way is that I can actually look at what I have here and add it up together. So the other expression that would represent this area is x squared plus, I have 3x and 3x, which would give me 6x, and then my 9 single units down here. So in this case, our units, because we're talking about the side of a actual quilt square, our units technically are inches. So this would be x plus 3 inches. This would be square inches because I'm talking about area, and that has a two-dimensional unit. So just to double check and make sure that this isn't wild and outlandish and crazy, you could actually substitute in some values for x and see if it really works. So if I substituted in x equals 1, for example, well, then I would have 1 plus 3, which makes 4. So I would have 4 times 4, or 4 squared, which would be 16. So then if I substitute that in here, remember I'm substituting in x equals 1, I would have 1 squared plus 6 times 1 plus 9. So I would have 1 plus 6 plus 9, which does also give me 16. All right, scooting back over to our presentation. All right. I need it now, computer. Here we go. So the customer service representatives are going to help write up some orders for Jessica. And there's two different ways that we could describe the area. One of them was the lengths of the sides, which was the x plus 3, the quantity squared. And the other one describes the area of all 4 sections of our block. That was the x squared plus 6x plus 9. So what they're asking us to do now is, if we've been given these side lengths, can we determine what the area would be? So I'm going to go back. I'm going to write these down really quick because otherwise I'll forget. All right. So starting off, I'm going to do x plus 2 with my algebra tiles, and then I'm going to do x plus 1 without my algebra tiles. So again, I'm going to put these on the outside to represent my side length. And then the inside is going to represent the area. So if I have a side length of x by x, that's going to become x squared as that area there. Now I have 1 by x, so those will become x's. I have x by 1 twice, so those will both become x's. And then I have 2 by 2, so I need to add 4 singles into this bottom corner here. So I'm going to take my side lengths away again so we can investigate just the area itself. So one of my expressions is x plus 2, the quantity squared, because that was our side lengths. And our other one is, now I'm going to add up what's inside here. Well, I have an x squared. I have 2x and 2x, which would make 4x. And then 4 singles, which would make 4. So those are my two equivalent expressions. Now, like I said, I was going to do the first one of these with the algebra tiles. Now I'm going to do this second one without the algebra tiles. And this is where those of you that had me for Math 1 are going to feel right back at home, because we're going to use the box method. So if my two side lengths are x plus 1, now to get from the outside in, we're multiplying. So x times x gives me x squared. X times 1 gives us x. X times 1 again gives us x. And then 1 times 1 gives us 1. So my first expression representing the side length would be x plus 1 squared. The other one would be x squared plus 2x plus 1. Now at this point, these forms should look pretty familiar to you. This first one is our vertex form. And this second one is our standard form. So what we're doing in this lesson is actually looking at putting standard form into vertex form and looking at the equivalence of those statements. All right, so that's if we had the side lengths. And then we were going to write the standard form equation from that. So patterns that we noticed relating the diagrams to the two expressions from our area. One thing that you might notice is that both of our statements had a squared term. We're dealing with area, so they would both have to be squared. You may notice a little bit of a connection between our b value in our standard form equation and the value of the constant that was inside of the parentheses with our variable in our vertex form. I'm not going to go too far into that just yet. I want to do a couple more examples before we talk about that relationship. But hopefully you've noticed some relationship between the diagram and the expressions at this point. All right, so Jessica likes to have her dog in the shop. One day her dog got a little hungry, started to chew up some of these orders. She found the orders, but one of them was so chewed up that she only had partial expressions for the area. So our goal is going to be to complete each of the following expressions for the area so that they describe a perfect square. So that means I want both of my side lengths to be identical. Too far. So these are going to be our 4 examples. I'm going to jot these down really quick just so I don't forget them. So our goal is going to be to actually find that missing piece to complete the area. So again, I'm going to go back to my document camera. So I'm going to do the first 2 using our algebra tiles, and the second 2 we're going to do using the box method without the algebra tiles. So I have x squared and 4x. So my goal is to start to turn this into a square. So I want my length and my width to be identical. So I can't have 4 here and none on the bottom. I can't have 1 here and 3 on the side. So it has to be split evenly into 2 and 2. So if this is what we have so far for our square, what would be missing would be those 4 single units that we had before. So that would be our missing piece here on the end would be plus 4. So the next one we have is x squared plus 6x, and we have to find this missing piece. So I'm going to take away these singles for right now. So I have x squared, 4, 5, 6. So again, this has to be a square. Side lengths have to be identical. So I'm going to take 3 of these and put them down here, and 3 of these and put them off to the side. So what would be missing here I'm going to have to grab some more, are these 9 singles from our corner. So plus 9 is our missing piece. And I think we were supposed to write an equivalent expression from this, and I totally forgot to do that on the first one. But we'll go back. So the other way I could write this, well, if I was going to look at what my side lengths here would be, and remember this is a square, so I would have 1x here, and then 3 singles along the side. So this would be x plus 3 squared. Now we are going to backtrack and go back to this one because I forgot to do this for the first one. So we had this. So I have a side length of x and then a side length of 2 singles. So this would be x plus 2, the quantity squared. All right. Now we're going to kick it up a notch and we're going to do it without algebra tiles. So the third one was x squared plus 8x. Now this is supposed to be a square. So when I break this down to put into the box, this was x squared. But I have to figure out how I'm going to split up 8x so that it's split between these 2 corner cells equally. So cutting this in half so that there's the same amount on both corners would be 4x and 4x. So what this piece would be, I have to multiply something to get x squared. So those would both be x's. The thing that would be missing to get 4x here when I multiply is 4. So this missing piece would be 16. And then we just figured out that this would be x plus 4, the quantity squared. So our last example is x squared plus 12x. So again, I'm going to draw the box. This will be x squared, so I know I multiplied side lengths of x. Now I'm going to take this 12x piece and I have to split it equally between those 2 corners. So that would be 6x and 6x. which means this missing piece would be 6. So I know I'm going to have x plus 6, the quantity squared. And then 6 times 6 would give me 36. So the missing piece here would be plus 36. All right. So if x squared plus bx plus c is a perfect square, what is the relationship between b and c? How do I use b to find c? And then I have those other 2 questions. So I'm going to go back to my document camera really quick, and we're going to answer that first question. If x squared plus bx plus c is a perfect square, what's the relationship between b and c? So what I'm looking at is, let me get a highlighter. I'm looking at what's the relationship between this number and this number. So you notice I kept saying I need to split this equally between these 2 corners. So these numbers are also an important factor in what we're looking at here when we're talking about completing this perfect square. So I kept saying I have to equally split this into my 2 corners. So I was taking 12 or 8 or 6 or 4 or whatever it was, and I was cutting it in half to figure out what those corner boxes should be. Then to find my missing piece, I was multiplying that value by itself. So I was actually squaring it to get my final answer. So I started with b. So really what I'm doing is b divided by 2. And then I'm taking whatever that is and squaring it to get my c value. That's what we were doing this whole time while I was trying to finish that perfect square. So the next question they asked us what if b was negative, would this process still work? So if, and I'm going to grab a different color just so we can see this. If this had been negative 12 instead of positive 12, could I have still done this? Absolutely. It would have made this a negative 12, which would have made those corner boxes a negative 6, which would have made my factors x minus 6. But negative 6 squared still gives me 36, because a negative times a negative is a positive. So even if b is negative, this process will still follow suit because I'm squaring a negative number and I'm still going to end up getting that positive c value. The kicker is going to be if b is an odd number. If b is an odd number, it will not evenly divide, so I will not get a whole number. I'm going to end up with a fraction, and then when I square that, I'm going to end up with a fraction for c, which I know is gross and probably makes all of you very anxious about the future of this unit, but I promise it's not that bad. But just remember, if b is odd, I'm going to end up with a fractional value for c. But I promise you, it's not going to be that scary. But just remember, if they give you a b value and they're asking you to find c to complete the square, I take half of b, I square it, and that gives me my c value.